room does look half full now, so thank you all for coming in early. This is the first of several events we're going to have over the next 3 days, and it's my pride and privilege, to welcome the Belgian Hydrogen Council here and their member companies as well. It's been a fruitful partnership since we signed the MOU. Not even 12 months ago, we've done quite a lot of activities together, and today Isabel and team, they've brought together some of the leading hydrogen companies in Belgium to speak a little bit about how they've been working on demand and creating that infrastructure for green hydrogen. So with that, I want to welcome Isabel and all her colleagues, and I think Isabel will introduce all of them. We have very interesting people, and looking forward to this. Thank you so much. Bye.
Thank you, Nish. So I'm Isabel from the Belgian Hydrogen Council. I will first see whether this works. Yeah. So first go to the full agenda. So we had some welcome remarks. So I will explain a bit about the Belgian hydrogen ecosystem as coordinator of the Belgian Hydrogen Council. And then we will have a speaker from AGFA, Zirfon, so which is an example case of our technology players in Belgium. Then we will have the Port of Antwerp-Bruges, who will explain about the infrastructure, first the hydrogen demand mapping, and then also the link with the legislation, so how legislation is pushing the amount of hydrogen and the market outlook for Belgium and also the surrounding countries. After that, we will have the presentations also of the Port of Antwerp-Bruges, and Fluxys, our national hydrogen backbone operator, and Air Liquide, which is developing or has already a cracker of ammonia and is developing a bigger one. So these people will talk about infrastructure developments in Belgium. Then we'll have a presentation from RMI and Vito, which is more about a study on the possibilities of the gateway of our port as gateway to Europe for hydrogen and ammonia. And then there's a panel discussion. So this is the agenda. And then I'll start, so here if the lineup of the speakers. Joris, you're not on the picture. Your picture was too late or was not there. So Joris there will also be one of the speakers. So this is the lineup of all our presenters. So something about the Belgian hydrogen ecosystem. So the Belgian Hydrogen Council is not a real organization. I mean, we have two different organizations which are coordinating a cluster of companies in Belgium. We have the Dutch-speaking part in the north of Belgium. They have their own hydrogen cluster, and we have also H2Hub in Wallonia. It's the French-speaking part of Belgium. They have a cluster. But we work together as Belgian Hydrogen Council because our governments like to have one contact point in our country and not two. So that's why we work together as Belgian Hydrogen Council, and in that way we are also the counterpart of other national organizations in Europe and everywhere else. So we are Belgian Hydrogen Council. And I work for Waterstofnet, which is the organization that coordinates the Waterstof Industrie Cluster. And in that function, we also coordinate the Belgian Hydrogen Council. So the scope of this council is that we it's a bit vague. We are an equivalent of other national organizations in Europe and abroad. We are advising our policymakers. We are connecting of course, the ecosystems in Flanders and Wallonia. And we also do profiling and promotion of the Belgian hydrogen ecosystem. In that way, we are also here with the Belgian booth in Hall 2, C2C90 is our booth. So we are promoting there our companies, and several of the participants here are also part of our Belgian booth in Hall 2. So, and we also organize a beer night that's also part of our promotion tomorrow evening at 5. So also important, yeah. So Belgian Hydrogen Council, so we have a lot of members. We have about, I think around 200 members in total in the two ecosystems, Flanders and Wallonia together. And they fill the whole hydrogen, the whole value chain. So we have research organizations, we have production companies, we have also infrastructure companies for transport, distribution and storage of hydrogen, several technology players, engineering integration partners, and application and end users. So we really fill the whole value chain with our members. The Belgian Hydrogen Council is also a board with a chair, so the Port of Antwerp-Bruges is the chair of the Belgian Hydrogen Council, and we have all these companies that are also representing the full value chain in the board of our Belgian Hydrogen Council. And we have, we work on policy, infrastructure topics, and promotion and international contacts with this Hydrogen Council. So this is our how we are set up. Then, as Belgian Hydrogen Council, we also worked on the narrative of hydrogen in Belgium. So, what are we standing for? What are we representing as country? So first, in fact, that strategy of Belgium regarding hydrogen is built on 3 pillars. The first pillar is that we are a big consumer of hydrogen ourselves. I think we are about on the 5th place in Europe regarding hydrogen consumption, whereas we are a very small country. So, but we have a huge consumption of hydrogen, especially in the Port of Antwerp, in the chemical cluster. So we are a large consumer, which enables our position, a strong position in the hydrogen economy. Secondly, we have the ambition to be a hub for import and throughput of hydrogen. We have the same role already for natural gas today, with a lot of transport to Germany of natural gas, and we have the ambition to do the same for hydrogen. Fluxys will come back to that, and also Port of Antwerp-Bruges on the building of the hydrogen backbone through Belgium, and also the terminals that are being developed for ammonia in the port. So throughput hub. And the third pillar is that we have several technology players that are really world-class regarding hydrogen. So for electrolyzers, for components, for hydrogen panels is also a very nice one. Several transport developments like CMB Tech, which is developing ships for ammonia. So we have several technology players. That's a third pillar which we want to develop further, and which also we would like to see exporting their technology to other countries that are active in hydrogen. So the 3 pillars. Some realizations. What is really built up to now is mostly connected to mobility up to now. So we had the first hydrogen refueling station in Belgium already in 2013. So that was really early, before the hype. Also with electrolyzer made hydrogen. We have with several demonstrations and first pilots with trucks on hydrogen. And we have about, I think, 9, 10 hydrogen refueling stations in Belgium already operational. This is the first bigger project which is built now, which will open at the end of the year. It's High of Wind. It's at the coast of Zeebrugge. It's in the part of the Port of Antwerp, Zeebrugge. And 25 megawatt electrolyzer is built there by John Cockerill, also Belgian technology. And that will start producing by the end of the year hydrogen for industrial and mobility use. It's built by Viria, which is a company it's an energy company in Belgium. So that's the first big project. We also have a hydrogen valley since very recently. So it was in the last call. It was approved, this hydrogen valley, and I think it was signed last week, the contract. So we'll start with the hydrogen valley around this project of in Zeebrugge with the 25 megawatt. That will be the main supplier of hydrogen, and a number of applications are built in the ports to work with this hydrogen produced there at the coast of Zeebrugge. So we have a first hydrogen valley also in Belgium. And then going back to the technology and introducing Nick with Agfa. So electrolyzer technology is really well based in Belgium. So we have electrolyzer companies, John Cockerill. We have also Exion, which is a smaller one, and which is in fact, we had also Accelera by Zero, but they have, from Cummins, they are decreasing or just stopping their activities. But several engineers from that company are working for Exion now, so two companies. And then we have, of course, Agfa that makes the membranes for the alkaline electrolyzers. Also Bekaert that makes the porous transport layers for PEM electrolyzers, and Bori that makes bipolar plates for PEM. So we have really well-known technology players all in that field of electrolyzer technology. So that's also an asset that we will try to develop further and try to export to countries such as India. Okay, but then that's I think my introduction. So I give the word to Nick from Agfa Zirfon as an example of our technology, and then I give you the clicker as well.
Okay, good morning all. Some of you might know me already, but my name is Nick Valks. I'm the business manager for Zirfon at Agfa. And Zirfon is a membrane being used in alkaline electrolyzers. So it's a very niche component, but I can tell you over the market in the last 15 years, we have spread out more than 4 gigawatts on the market. So we are today, I think, the number one for alkaline electrolyzer membranes except for PPS in China. At the same time, I think all the bigger European projects and also the first 100 megawatt project in India from IOPCL will also be with Zirfon, as we are the provider for LNT as well. So we are present and we are active in the Indian market. But I will come back on that. I will not spend too much time. So what you typically have in electrolyzer technologies, and I'm sure some of you are either providing components, some of you are either buying electrolyzers or producing hydrogen. You have classical alkaline water electrolysis, the ones which exist for 50, 60 years, or even longer, which are the traditional Chinese ones where a PPS felt, the traditional vacuum bag that you used to have in your vacuum cleaner, this white bag, that's a PPS felt. So that's actually the membrane that's being used in traditional alkaline electrolyzers in China. You know all the big names there, Longi, Sungrow, Peric. And we are actually active in the advanced alkaline water electrolysis, so you produce more, you have a higher efficiency, you have a lower LCOH, and especially, and I think also with all the incidents that have happened on the market in the last 3, 4, 5 years, also in China, and also some of them in India, we are actually focusing a lot on safety. So if you buy an electrolyzer with a Zirfon inside, 17 years incident-free. And then, of course, you have the PEM electrolyzer systems as well from known companies. Our customers today, the known ones, the bigger ones in Europe, Nucera, there we are exclusive supplier. Sunfire is running all with Zirfon inside. Stiesdal and John Cockerill, for example, the High of Wind project that you just saw is also with us inside. So who are we? I think everybody knows us from the camera. The photographic film, 120, 150 years ago, we exist for more than 150 years. That was Agfa. We have diversified our portfolio. We have done pre-press in the meantime. We have healthcare IT, so totally different. We have a presence of 50 people in India. We have an office in Mumbai, close to and we also have presence in India for Zirfon itself. Rucha, maybe some of you will know her. Rucha Chevte, she is actually heading our business in India today. And if you look, we introduced Zirfon on the market 17 years ago, so a long time ago. Originally actually developed by our colleagues, which are also present from Vito. But we commercialized it. So if you look at it, you typically have an electrolyzer cell. I'm not sure if there is, yes. An electrolyzer cell, anode cathodes. The guys from BVK can tell you anything on the electrode sides. But you have a membrane inside, and the membrane actually needs to make sure that these two gases do not see each other. If they see each other, you get an explosion. So that's the reason why safety is so important. And if you look at it, what we've actually produced is we have a PPS woven mesh as a support layer. We coat zirconia and polysulfone on it. So it's not rocket science, but it's really difficult to produce in a steady state environment. Now, why choose people us? We are proven, we are at scale. I will show you quite quickly how large that we actually produce already. Lowest energy consumption. So your capex of your electrolyzer might be a bit higher, but 75% of your cost of your green hydrogen is electricity cost. So if you have your electricity more easily set in, more efficient, you will still have a lower LCOH. In China, this nobody listens to me. Trying to, but it's difficult. In India, we do see that there is a narrative. So, and then, of course, guarantee safe operations. So, what do we have on the market? I think the first one is in Belgium since 2007. We have 5 megawatt alkaline electrolyzers operational as of 2009 in Iceland, in Norway, in South Africa. We are used at ISS. So the oxygen produced in the space station, International Space Station, actually is produced with Zirfon inside. It's an Airbus stack. We are used in submarines. So actually for South Korea, to also produce again the oxygen. which are actually four submarines of 5 megawatt, and they now start to replace after 8 years of operation. So we know that we are also in critical situations, you can use us. In 2023, we received funding from the European government for a gigascales project where we started a new production facility. Some of you might have seen it during the last visit from GH2. And always more than welcome, we will open up our doors where we produce up to 20 gigawatts per year. So it's a huge capacity where we can supply the full market for in the coming years. And we've opened up last year. Today, we have over 20 electrolyzer players which are actively using us in the area of India. So as I said to you already, L&T, but we also have Bharat Petroleum is using a 1 megawatt electrolyzer from us, Eastern, Newtrace, Pratishna, all electrolyzer players in India which are actively working with us and have a first megawatt running. And again, also as I mentioned, the first 100 megawatt project will also be with us. This I will skip because I mainly explained it already. But I think what you should know is that if you buy from us, you can use us for such a long time. There's no risk. We have proven more than 10 years of durability on the market. We are safe. There's no incidents, and I think that's a crucial part. So what you see actually over here is today a capacity which we have as 1 million square meter per year. So we can represent more or less 20 gigawatts per year. At the same time, we also know local value addition is critical also for the Indian market. So what we are doing is we are trying to source the polysulfone that we use, the PPS mesh that we use. We also got the official approval from the Indian government that this will be seen as local value. So if you actually start buying materials for the Indian market, if we source partially from India, this will count as local value, which I think is also critical in your projects. And then actually we've done an additional investment already in the new production line to go up to 2 meters, especially for the Indian and China market, where we see that there is the need for larger sizes. So we will improve and actually enlarge our production scale on that side. Now, why are people using us? And I know it's technical, so I'm very sorry for that, but I'm a technical sales guy, there's nothing you can do about it. But what you actually should see is this is the electrons, this is your renewable electricity coming in, and this is the efficiency, the voltage on which you can produce it. And what you actually see here, this is a traditional China stack. If you just replace the PPS that this electrolyzer producing is using and use zircon inside, you will get 100 millivolts, which actually represents 3 to 5 euro cents per kilo. It's huge. If you have 100 megawatt projects, it's paid back in less than 2 years. And then, of course, we see that all people working on advanced electrolyzer systems, they use different type of electrodes. And then it becomes even more efficient. And this is the safety part, which is the most crucial one. If you have a dynamic electrolyzer, your electrolyzer is going on and off, and there's less wind, there's less solar, you will see that this, again, is the same curve as you saw before. This is the amount of electricity coming in. So your electrolyzer stack from China, it can go down to like 50%. So about this area, what you will see is this is the hydrogen to oxygen. So it's the amount of hydrogen crossing over towards your oxygen side. If it's at 2%, you have to switch off your electrolyzer. It becomes unsafe. At 4%, you will have a natural explosion. So, and what you see is actually our customers, they can go down to 10 to 15%. So instead of switching off, your electrolyzer can start running, ramping up. During a ramp up, you have pressure differences between hydrogen and oxygen. The PPS just lets it flow through. You can see through it. So also the gas will go through. In our case, we have a barrier. And the barrier actually makes sure that your electrolyzer has 30 to 40% more uptime. If you put that in your LCOH calculation, you will immediately see far more efficient, far more safe. And actually what you see here, this is the reason why there have been so many incidents. I think everybody is aware of the Kucha incident a few years ago. It's this graph. They can't cope with renewable electricity. And this actually is the end of my presentation. So what we have done actually here, and I'm more than happy to go into discussions because it's a quick, dirty calculation. But the electricity price calculated more or less 30 euro per megawatt hour, so typical, I think, for the Indian market. We have put there uptime, and then the prices per kilowatt, they might be too expensive, I'm aware of that. But if you just see the efficiency gain, electricity cost, you see, is a big part of the calculation. But you get pretty close to today's euro per kilo, dollar per kilo price in India. And there you see 8 cents. Doesn't look a lot, but if you're producing tons a year, it's a very quick payback. So we have a booth together with the Belgian Hydrogen Council. If you're in the area, just drop by. More than happy to explain further in more detail. Thanks.
Thank you. Yes, good morning. I'm Gilles from Port of Antwerp Bruges, but I'll present in name of Belgian Hydrogen Council a bit of an analysis that we've done on the hydrogen demand mapping in Europe, and more specifically focused in Belgium and its neighboring countries. To zoom out a little bit, first to start with the bigger picture, you see some European politicians here on the slide, and it's mainly to state that hydrogen and the clean hydrogen market is a policy-driven market. Hydrogen is a gas that's being consumed today, but making the switch to clean forms of hydrogen is mainly policy-driven. Costs are high, there's no real incentive to make the switch, so it's a strategically political decision that has to be made, and that has been done a few years ago by the European Commission, European Parliament, with the Green Deal. The Green Deal sets out a lot of regulations, directives, and so on that set the ground rules for hydrogen developments in Europe. And we can discuss on the feasibility and how high the bar was set, I think, a few years ago. But the bottom line is that those discussions have been overcome or has been passed in the couple of years. The European framework is clear with the ground rules for regulations for infrastructure developments and so on, but also on the end use, what are targets, where are we going, how much hydrogen should be consumed. And recently, and now, we've seen that from this European level, we are making the transition finally in the last phases to national implementations. And I think that's where I want to focus. How does then this framework, this European ID that has been established, discussed over the past few years, how does it now concretely land in the different countries, Belgium, the Netherlands, Germany, France? Focusing on Belgium, because we're the Belgian Hydrogen Council, we are in close contact with all the political administrations that are in charge of implementing this, and we want to focus a bit on the Red Tree. I think the Red Tree sets out for hydrogen a target for use in the transport sector and in the industry sector. And we clearly see that in the transport sector, you get a realistic case where you can use green, clean hydrogen. And so, which can be a first level of the adoption of green hydrogen in your industry. The discussion on the implementation of Red Tree and specifically transport has been ongoing for the last year or so. You see that in June 2025 we received a first draft, which was quite favorable. I think the next slides shows a little bit some of the details and what we think is a good way forward to create scale, to create first demand, is that the use of green hydrogen in refineries can be fully counted for your transport targets. And the benefit here is that Belgium, in the Antwerp port area, has 2 big refineries, which already consume a lot of hydrogen, which can relatively easily, what you understand under the term easily, but can transition to the consumption of green hydrogen in that refinery and thus create scale up to hundreds of kilotons of hydrogen, can be really first demand pool, which was also supported by the Belgian government. So they clearly stated in their political mandate that they want to incentivize this and see this as the main offtake route for green hydrogen. BHC, of course, welcomes these proposals, and since June 2025 we have been working, discussing with the political cabinets on now firmly putting this into law so that then investments and so on can continue to be developed. To give a bit of an overview, what's then the current status of this RED III transport implementation in Belgium? You see, you don't really see the pointer on the screen. You see here the graph, and I think this has been developed over the past couple of months. There was initially a framework that sets the target for 2030 alone, but now, which is quite positive, there has been a trajectory developed towards 2040, indicating a growing hydrogen needs and thus creating the necessary stability, predictability for the market to send or to consume hydrogen in its transport and refinery sector, with a 4% target in 2030, rising to 8% in 2040, and also with a target for the maritime industry to consume hydrogen and hydrogen derivatives. If you translate those percentages, because it doesn't say much in the end, to what's now the actual demand, given that, like I said, Belgium hosts 2 large refineries, also hosts quite some maritime applications. You get around a green hydrogen consumption mandate in the transport sector of around 70,000 tonnes with that 4%, and so that will rise in the years thereafter. Also important is that to enforce this, there's been quite a strong penalty system being suggested, and so if you see the price of non-compliance, it's quite high, and we believe it's higher than the price of complying by buying green hydrogen if we see the prices from India and the rest of the world, for example. So which sets the bar high enough to not just pay the penalty. Also multipliers are being used so to incentivize even more the use of hydrogen compared to, for example, biofuels. The second element in the RED III is the industry target, which says that hydrogen currently being consumed in industry should be replaced by a certain percentage for 42 by 2030 and 60% by 2035 by green hydrogen. This is a bit of a This has always been a bit of a strange addition to the RED directive, and has a quite substantial effect on Belgium, just because there's also quite a large industrial sector, a chemical industry that consumes hydrogen today, which then need to fully transition in only a few years' time to green hydrogen. You see the numbers, it's 250 kilotons of hydrogen consumption, so the challenge there is high. You can have some exemptions, the use of blue hydrogen with a famous project that we have in the port area, but still the challenge remains quite substantial, and so we strongly advocate with our politicians to, if this target gets transposed, which is still an if today. We see in our neighboring countries that also there's a lot of discussion on this industry target, but if it gets transposed, there's a strong need for funding to cover this so that the burden doesn't lie with the industry, which is already struggling today. And an interesting mechanism that we try to propose is an HU Global Window, where you can bundle forces between a producing country, for example, India, and an off-taker country, for example, Belgium or Germany. Work in progress, I would say. Switching to our neighboring countries, I'll go a bit faster here, just to give the overview of what's the status there. Also, Germany is mainly focusing on the transport sector for its demand creation, with also a percentage trajectory up to 2040, with 10% of hydrogen being consumed in the transport sector by then, or a mandate at least for 10%. This results in quite substantial demand volumes. Oh, again, too fast. Of more than 200,000 kilotons of hydrogen already by 2030, and so up to several or at least a million tons of hydrogen later on. Also, the penalty scheme here is quite high, so there's a clear incentive also for refineries to consume large quantities of hydrogen in their refineries. An additional one is also the power plant strategy, which you might have heard of. So there's tenders ongoing for new energy capacity, since they have decided already a few years ago to phase out nuclear, or to close nuclear, to phase out coal. And so new gas-fired power plants that need to be hydrogen ready are being tendered. So that could potentially also create some additional demand in the long term. Looking at the Netherlands, you have a framework which is recently adopted. Also, Germany was recently adopted. Belgium is still in the last discussion phase. And there you have targets in the road sector of 1.45, maritime sectors targets comparable to Belgium. But you see that the trajectory, the predictability after 2030 is missing. You get around 100,000 KT demand in volumes, but it's unclear if this will be the total demand, or if there's still a cap, for example, on the refinery use. So it could be better, I would say, in the Netherlands for demand creation. And then in France, also quite a positive or a strong signal has been sent, with a clear trajectory up to 2035, large volumes, also more than 200 KT being mandated, large penalties. So a certain larger market is being created there. To summarize, the target setting, the percentages are not always on the same basis, are not always uniform. So when you compare apples with apples, if we do the calculations, you see France, Germany, Belgium are quite in line, Netherlands a bit below. But if you then translate this into volumes, you see that Germany, France, but also Belgium, also the Netherlands, volume-wise create around a market of more than 500,000 million tons of hydrogen demand in the transport sector alone by 2030. And so with the frameworks that also go beyond 2030, there's some predictability that this demand will even grow. Important, like I said, the penalty system is set high in Belgium and in our neighboring countries. Unclear about the Netherlands, but this ensures that it's better to comply than to pay the non-compliance penalty. All right, that was it, and I think I continue a bit with the port development. So now I'll put on the hat of Port of Antwerp Bruges to introduce us a little bit. We've seen the demand creation right now. We strongly believe as a port that these refineries, this transport sector stimulated by RED III, is the main or the base demand sector that can build the hydrogen economy, referring back to the Green Deal, the the mindset back then was a bit different. Hydrogen would flow in quantities unimaginable. We are now in a more realistic period, but we strongly believe still that in those refineries you can get large demand. And with Port of Antwerp Bruges, we host 2 large refineries, but we are also internationally connected. With the daughter company, Port of Antwerp Bruges International, that's developing ports globally, that also provides training, but of course also with all types of maritime connections that sail to and from Antwerp Bruges. And this also means, or that allows us to position us as an import hub, a hydrogen import hub, which we think will be the main route to comply with the demand that we've seen. I think something went wrong with the slide here. It's just to indicate a little bit our presence internationally, but I'll skip it and then focus a bit on what's ongoing in Antwerp. To host or to set up this hydrogen import value chain, of course, when zooming in on our core, which is the port in Antwerp and in Bruges, is to develop additional infrastructure to enable that import value chain. We see ammonia as the main hydrogen carrier being put forward, and so additional ammonia infrastructure needs to be developed. We have in the port several projects ongoing by present terminal operators, Vopak, Advario, VTTI, Seatank, to build additional ammonia tank capacity. The ammonia can then flow into the ammonia markets, so then you only need a tank. If you need to convert it to hydrogen, you need an ammonia cracker. And so 2 projects also by Air Liquide, Air Products, are ongoing to crack the ammonia back to hydrogen. Connecting everything in the port area is also key. We have or one of our strengths in the typical industry, the chemical industry, is this interconnectivity between different companies. And so also in this domain, building out hydrogen pipelines, being constructed currently by Fluxys, but I'm sure Fluxys will elaborate on that, but also building out an ammonia pipeline that can connect between different companies is being developed or ongoing. And here you see it a bit in a map form with the different projects in Antwerp. Also Zeebrugge currently does quite a lot of LNG imports. So is a major gateway for European gas consumption. And in the longer term, we also see imports of hydrogen carriers over there, which can then by hydrogen pipeline be connected with Antwerp, or even further on connected with our neighboring countries, Germany, France, the Netherlands. And maybe one element to highlight still, besides all the additional developments that are ongoing, if we're looking at ammonia as a hydrogen carrier, ammonia is not an unknown substance to us. It is currently being produced, stored, consumed in the port area, transported. There is an ammonia pipeline in the port area. There is ammonia being put on trains and barges. And there is a good framework to handle all of this. The Seveso framework that covers the chemical industry is present to do this in a safe manner. There has been, or there is a feasibility framework, let's say, or safety framework in place that needs to assess whether additional capacity can take place. And so this is being covered. The main standard that's always been put forward is PGS 12. It's a Dutch standard, which is not completely taken over in Belgian legislation. However, in Belgium, when you do this analysis, this feasibility of where can I put my my additional ammonia infrastructure. PGS-12 is also something that is often referred to by the authorities to ensure that everything is in line with the safest guidelines with Seveso and so on. So we are confident that ammonia as a hydrogen carrier in additional developments will be able to take place in the Antwerp area. So that's from my side to conclude, to give a little bit of overview on what's ongoing in the port area. How can we bridge the connection between international developments, hydrogen, ammonia imports, and then the demand we see slowly rising, and what infrastructure you need for that in the port area. More information on our website, or feel free to contact me.
Hello, my name is Marcelino Cancela. I work for Fluxys as business developer, and today I will explain you a little bit about Fluxys, about the company, about our infrastructure plans with respect to hydrogen pipelines in Belgium and their connection to other countries, and also about one of the projects that was referred before, the terminal in Antwerp. So Fluxys. We are basically known as the TSO, the natural gas TSO in Belgium. We do transmission, natural gas transmission, but also LNG terminaling and storage in Belgium. And we connect also our gas to the gas network to the neighboring countries, of course. But we are a little bit more than that. I would say much more than that. We are a multi-molecule infrastructure partner. So we are really developing on hydrogen and CO2 as additional molecules in our portfolio. We do that also internationally. So we are not only in Belgium, we are across Europe, mainly with natural gas operations. So we have pipelines in Germany, also from Greece to Italy, the transatlantic. We have a connection to the UK. So it's an international operation, which also looks outside of Europe. So we have presence in Oman, in the Middle East, and also in South America, Brazil and Chile. The company is about 1,300 people, spread mainly in Belgium, but also in other countries. And we are basically a public-private shareholder, which we have a private-public shareholding, which allows us also to look into projects in a long term, as a long-term partner. So our strategy is to enable the energy transition, and for that we base ourselves in 3 pillars. It's about secure, so to have a sustainable and secure energy supply. It's about expanding, so expand our operations in terms of molecules, but also geographically. And it's about connection, so to create the connection between value chains, between countries, between different infrastructures. And I will go through how we started with the development of the hydrogen pipeline infrastructure in Belgium. It all started in 2021. We followed a collect, match, and propose type of approach. So we approached the market in 2021 with info sessions, with a request for information, in which we asked the market to provide us information of what were the plans with respect to hydrogen, who would be consumers, who would be producers. And we used that information, we collected, we aggregated it, we gave feedback on what we got to the market, and we used that to basically understand where the supply was coming from, where the demand was coming from, in order to, well, first of all, propose a network system that could match basically the needs that we saw on this RFI. Based on that, we engaged with additional, with the customers that would want to take a further step. They make reservations with a fee, so there was already some level of commitment, a low level of commitment, but a level of commitment. And based on that, Fluxys developed feasibility studies to ensure that the connection of those either demand centers or supply centers could be connected to the network. And right now we are in the phase where these commitments that we need to be combining in order for us to be able to actually build the network. We already started to build the network with a small, shorter pipeline between Ghent and Antwerp. I will go through that. But in order to go to the next step, we really need to have this further engagement. And we also need to have, with our regulator, the whole tariff structure, the commercial contract structure also finally integrated and arranged. So as I was saying, we use all the information to propose. And what we propose is this network, which focuses mainly on connecting the main centers of demand, Ghent and Antwerp, so the industrial ports. But it also focuses on the interconnections with other countries, with the Netherlands as a potential also supplier of green molecules, and with Germany as the main future consumer. So where Belgium could become a transit hub to bring molecules to Germany. And of course, we also look, and this is also important, but I say that will be on our next step in the possibility of repurposing some of the natural gas pipelines into hydrogen. But in order to do all of this, there needs to be some level of certainty that the business model can be developed and can be established, and that had to be done in Belgium, it's done in a regulatory way. So there was a federal strategy, hydrogen strategy, proposed already in 2021. It was improved in 2022. And that was translated into the Hydrogen Act, which is basically the transcription of this strategy into the law. And this law established the presence or the need for a hydrogen network operator, which had to be designated. So that means that there will be one single operator of the network, but that would work with regulated rules and regulated tariffs. So based after this, Fluxys already established Fluxys Hydrogen, that would then later apply to become that hydrogen network operator, and it was finally awarded in 2024. So Fluxys Hydrogen is nowadays the hydrogen network operator and has the certainty to develop the network and to invest, knowing that there will be a regulated system where we could rely on. After becoming the hydrogen network operator, we wanted to kickstart things, and it was decided to already establish the first pipeline. It was started the construction in 2025, in March 2025. This is now being built. Is the connection between Ghent and Antwerp, and this is where we see that the main demand centers in Belgium will be located. After that, what we see as a priority is the connection to the Netherlands, which is just a smaller connection via the north of Antwerp, and of course the connection to Germany. Of course, there's a number of challenges that remain and that make that we cannot directly start building. First of all is demand and supply, they need to be confirmed. So there need to be some commitment from the customers in order for us to be able to continue building. And of course, on the regulatory point of view, we also need to arrive to have a established commercial framework, which is accepted by the regulator and where the tariffs are established. And following on that, so on the next objectives, we signed a JDA, a Joint Development Agreement with Gasunie, which is our counterpart in the Netherlands, in order to establish this connection point between Antwerp and the Netherlands. The JDA also foresees the possibility for 2 other connections. But first of all, what it will be done is to address the market again with market consultation in order to understand better which is the actual commercial demand for such a connection. In a similar way, we are discussing intensively with OGE, which is the German counterpart, in order to establish also the corridor from Belgium to Germany with a capacity of about 3.8 gigawatt. This discussion will need to be confirmed within this year. We should have a JDA, and also in parallel, we will start together with OGE and with a common approach, also a market consultation that will lead also to some level of commitment from potential customers in order to start this project. The connection to the Netherlands is something that can be done faster because it's a much shorter investment, a much smaller investment, a shorter connection. With Germany, we're talking of around 2032 to have this connection available. And yeah, to finish, I like to also present our terminal project in Antwerp. Actually, we do this together with Advario. It was already mentioned before. So this is one of the terminals that is being developed in the Antwerp area. The project is quite mature. It's currently on the FEED phase. So basically, we are getting ready to take FID. Of course, FID can be taken again, as I was saying before, once customers are really willing to sign the paper. But we will be ready for that within this year. So FEED will be finalized in June. And this terminal will, well, you already see a visual here. There is the possibility of 2 tanks or even a 3rd tank. For now, the focus is, of course, on the 1st tank. We will have the possibility of large vessels importing ammonia into our tanks. There will be the possibility for export through barges, through rail car here, and also through the pipe link connection, which was mentioned before, in order to allow to move ammonia from the terminal to potential consumers in the port area, and also to the cracker of Air Liquide, for example. So that was my presentation, and yeah, happy to answer any question later on. Thank you.
Good morning, everyone. I'm happy to be here. My name is Robert Hefner, and I work for the company Air Liquide, and there I focus on public and regulatory affairs. I'm actually focusing on the Netherlands, so it's a special honor to be here to talk about our project in Belgium, in Antwerp. And I want to tell you a little bit about Air Liquide, and especially about our ammonia cracking projects. So let's see how this works. The green arrow, that's quite logical. So to start with the introduction to Air Liquide, well, many of you are probably aware, we are a multinational company. We have 66,000 employees, and we are present in 60 countries in the world. That's the summary. I don't want to tire you with all the other figures. And our scientific territory is basically the small molecules. We produce all kinds of gases, except natural gas, of course. So Air Liquide started by inventing a procedure to split the principal components of in the air. So oxygen, nitrogen, argon, these components are a baseline. And gradually the company also developed into basically managing our other natural resources, natural gas based. So we produce a lot of hydrogen and other gases like carbon monoxide produced together with the hydrogen. And we also manage a lot of CO2, so we've been capturing CO2 already for quite some time, and we deliver that to the greenhouses and to the food industry, for example. So in hydrogen, turning to hydrogen, we've been active in their hydrogen value chain already for 60 years. So producing 1.2 million ton annually, more than 1,000 people working in the hydrogen field across the world, and also in the Benelux region. And for hydrogen, when we talk about hydrogen, we talk about the hard-to-abate industries, where we want to decarbonize also the hydrogen that we deliver, and also to decarbonize heavy-duty mobility, especially in the Netherlands, but also in Belgium. You see a lot of grid congestion, and that makes it difficult to also to electrify your heavy-duty transport, and also for that, hydrogen is a potential solution. So what do we do? So basically what we do is we source the energy, electricity, natural gas, And then we produce the gases, we capture the CO2, and we purify it, we liquefy it, or deliver it in gaseous form to our customers in industry and mobility. So the middle is basically our core business, production and conditioning. And in the Benelux, we have a pipeline network of more than 2,000 kilometers. It's not only hydrogen, but it is also hydrogen, so also oxygen, nitrogen, etc. And several units. So for talking about hydrogen, we have 7 units actually now sourcing our hydrogen network so that we can deliver the hydrogen to our customers. And we have various energy transition projects also ongoing within the Benelux. So notably carbon capture and storage, both in Antwerp, the Kairos at Sea project that was already mentioned. And also in the Netherlands, the Portos project, where we capture also CO2. And also various electrolysis projects. So we're building a 200 megawatt electrolyzer here in Rotterdam, actually on Maasvlakte at this moment. And that will also feed the network. And I'm coming to our cracker project in a moment. So basically we see we have 3 tracks when we talk about decarbonizing or basically delivering a low carbon product to our customers. First of all, the electrolysis. Second of all, low carbon hydrogen by capturing CO2. And third of all, of course, sourcing the hydrogen or in various forms, hydrogen carriers from abroad, and cracking it and delivering that to our customers. And we have projects in all 3 the tracks. But I'll focus on the third one for now, which is the ammonia cracking project and the pilot installation that we have already tested in the port of Antwerp, which is called ARCAS. So, of course, for this audience, it's quite clear why do we want to do it? Because in other countries in the world, there's a lot more renewable energy available at lower cost. So that's why it's very interesting to source hydrogen carriers from elsewhere, such as India, to ship it to Europe, to Antwerp, and then crack it back to hydrogen, or use it directly, of course, in the form of ammonia. And how does it work? So I'm very curious. I hope this video works. It doesn't look like it, because there's no button to I don't know. Can you Google Air Liquide ammonia cracking? Great. It's not cracking at all. You need to get out of the presentation, I think, and switch to the YouTube window. So. Yeah, there's the window, yeah. So this should be it. It always helps to keep the audience awake, video. Okay. Great. Yeah. Yeah, indeed, that's it. And then, we'll start. Great, thank you very much. Great, thank you very much. So the video is available on YouTube, so if you want to watch it again, more than welcome. If we can move to the next slide, please. Or that I can do myself. So yeah, so Arcas is a pilot installation actually. So we thought of doing this project in 2022, and it's been running from 2025. And basically the objectives of the pilot was really to test the catalyst, test our own technology, especially the catalyst and also the materials, to ensure that the material is durable and resilient. And of course, what's also very important in Europe is the nitrogen that you emit, nitrogen deposits, because they have an impact on nature. So you need to make sure that your process is as a low nitrogen. And for that, it's important to test the burners that we use to ensure that nitrogen emissions are not too high. So these were the main objectives, to really test the technology under various circumstances and under various loads, of course. And on the left-hand side, you see the model of the installation, and on the right-hand side, you see the actual installation, which is located at the BASF site in Antwerp, where we also produce hydrogen at the moment. Yeah, the findings are very generally summarized that indeed our safety protocol, that worked effectively with personal ammonia detectors and various monitoring points across the site. Also that the catalyst activity, etc., that they, as we had measured in the lab, that they were confirmed, and that more than 98% conversion could be achieved. Yeah, basically smooth operation. So temperature, control of the wash column, leaks. Luckily, leaks were very much under control, and indeed keeping the emissions also under control. So less than 25 milligrams per normal cubic meters by selective catalytic reduction. Yeah, so we're of course that's the way Air Liquide always does it, to kind of start small and then try to scale up. So we're now here at the stage of the industrial pilot, and of course we want to further scale up to have a first commercial plant, as already mentioned by Gilles. And we have a project for that has actually already been granted an award by the Innovation Fund, and the project is called Enhance. And what Enhance basically does is to scale up more than 30 times this pilot plant that we have, and to convert an existing SMR, so steam methane reformer, that is now used to produce hydrogen, to turn that into an ammonia cracker. Basically, what's also part of the Enhance project is a liquefaction unit, so that the hydrogen can be delivered in various forms to customers, also in mobility. Of course, when you liquefy it, it becomes also more interesting for mobility customers, such as shipping. And this cracker will be located in Antwerp as well. So that's our Enhance project. So that's the next stage of it. And that's basically what I wanted to tell you about our ammonia cracking project. Thanks very much. So who's next?
Okay, I'll skip. That's a lot of backup slides. Okay. Very good morning, everyone. So I have a very big responsibility on me, because I have to tie back all the big presentations made and convert it back to what is India-EU Green Ammonia Clusters and Corridor story. So I am Ankur Malyan, and I'm a manager at RMI. So many people who know, or some may be aware about RMI. RMI stands for Rocky Mountain Institute. It's a 44-year-old institution, started in US, and We have been working in India for last 10 years, and we call ourselves as Think, Do, Scale Tank. So because we are not just doing research, we are actually getting into more real projects, supporting market mechanisms, supporting implementation, and really making things happen. What is going on right now. So we are doing this India EU Green Ammonia Clusters and Corridors project with our partners Vito. Joris is here; he'll be presenting after me in more detail. So under the clusters and corridors thesis, which RMI is running in India, we have two initiatives, and I'm talking about one of them. Some of the people in the room are aware about our Tamil Nadu Green Shipping Corridor, which is running from Rotterdam to VOC to Singapore. I'm talking about today the corridor from Odisha, which is east of India, to the Europe, where we have kept an open gateway, which could be Antwerp, Rotterdam, Hamburg. I'll be focusing on Antwerp today with more details given the room. There is a reason that why this Odisha is being chosen. Like there is a whole deep dive assessment that we did, and there is a ecosystem that is emerging in Odisha, and it's a dual market that we say. It's not only the export, but as you see on the right side of the screen, that Odisha has its own ecosystem. It has two ports, which is Paradeep and Gopalpur. It has two fertilizer units which provide the domestic market. The lowest prices that you see right now coming out of India were actually taken up by these two fertilizer units, which I'll be sharing more about. There is a refinery, there is steel market that exists. Given all this, Odisha has a potential of having its own domestic market, but there is also an potential of exporting to Europe, which the previous presentations were talking about when the renewable ammonia or green ammonia comes to Europe, right? I don't think I'll have to go much in detail, but India has a lot of projects that are coming up. Announcement is one, but we have almost like 4 million ton approximately capacity, which is now being trying to orient towards exports coming out of India, and the prices are fairly very low. So the if you would have asked me this question like say 7 or 8 months ago, I wouldn't have the answer because nobody have discovered the prices back then, right? But now the prices are discovered, and it was auction price that people have signed up for, and also now the agreements are signed, so it's more formed up. So we can go as low as like $570 per ton, and the range goes up to like $744 per ton of ammonia, which is fairly very competitive. If you look at the global prices, the last discovered price in Germany was like 1153, so it's 35 to 50% lower, which we are talking about. I'll be going to the shipping cost also, but this gives an advantage to India to actually supply to Europe at a very fairly competitive and reliable price. It's not that we are just looking at Europe, but there is a domestic market. It is just have some time to scale. So the domestic market will be exploring. There is a near-term recent offtakes that have been signed, but fertilizer, as we all know, that it's a regulated sector in India. There was a two-side intervention that was happening, but there will be other sectors that will emerge. There is an interest that is emerging with what is happening in West Asia right now, and the interest will actually deepen as we go forward. We expect that the domestic markets will be scaling, but in near term, by 2030, it's not happening because the sectors are very price sensitive. Even the marginal change will actually impact the consumer significantly, and especially for the biggest fertilizer sector, it links to farmers. So the fertilizer price at the end is actually fixed. So there is no gap that you can actually absorb that shock. But we see that that's why Europe will emerge as a first buyer. Also, it will provide scale, but as I was saying in my first slide, that it will emerge as a dual market. There is no only intent to be exporter or only intent to be just domestically supplying. There is a dual market that India is targeting, right? Coming from the delivered cost, so it's not that we are only producing cheap, but even if you add the shipping costs, the cost that you pay at the port in India, the cost that you pay at the port in, say, location like Rotterdam or Antwerp, right? The shipping cost is also very competitive. So when we look at the willingness to pay compared to all these countries that we all talk about in the world, right? We are also actually at the lower end of it. So we can supply at a very competitive price. And also we are not supplying just, it's not just the India ambition, right? even the recalibrated demand, so why I say recalibrated, that we used to have like this 10 million ton volume, which was surfacing, right? It's not 10 million ton, we all agree, right? But whatever it is lower, recalibrated, but real. That's how it is emerging. So there is a real market that we are looking at in Europe, which India can supply. The real market comes from chemicals, refinery, and the fertilizer. So we see that the mandates itself can go up to like 2.8 million ton hydrogen at this stage, delivering to all these three main sectors. Transportation have been talked about. We have not kept it because of the own analysis that we do. But there is a strong possibility of supplying to chemicals, refinery, and fertilizer for sure. Right? When we look at all these three locations, whether it's Hamburg, Rotterdam, Antwerp, these three are the gateways where India can actually supply their molecule. But there is a very important region of Germany which we all talk about, like the connectivity, which Fluxus was talking, right? That there is a need for that connectivity to the heartland of Germany, North Rhine-Westphalia, where the lot of demand will come up, right? There is a volume that we have estimated, and it's a significant price of the size of the volumes that we can look at. But when it comes to that there is a supply coming out of India, and there is a demand in Europe, but is it just that the supply and demand will naturally match up, right? It won't. It should have been. Commercially, it happens, but there is some inertia that is happening. So we see certain gaps. So I think there are players from India here. They will agree that India has, and especially Odisha, has a lot of large announcements, but infra built out is slow. That is happening, right? There are fragmented developer plans. So individually, everybody is doing everything. But there is a need for this integrated work plan or the cluster development that it happens. Because when you're talking about the infrastructure, how ports will develop, they will have to ensure that there is a common user infra, and the commonality that can be developed, it optimizes price. And then there is a disjoint state processes. So like obviously you have center policies, you have subnational policies, everything has to align on time to make it happen. Similarly, like on the EU side, there is a storage and capacity that needs to reach scale. I think it was very promising in the previous presentation that it's happening, but it needs to have a scale because scale will bring down that cost, right? There is a weak demand aggregation right now. There is demand, I think we all agree, like it's all there. I think, but there is an aggregation effort. H2 Global is doing their closest partner to RMI. They are doing it, but I think there is a still need for aggregating demand and certification. I think I won't go deeper, but certification is also one of the problems. We see an opportunity in this because the Odisha EU corridor, how we position, actually needs a stronger coordination. It needs a neutral entity party who can actually make that, ensure that we are not party to all the commercial agreements, but we are ensuring that all the knowledge is there. Whatever is required to make the decision happen is out there. So there is a need for this integrated framework, which talks about around 3 pillars. One is the policy, like we all agree that there is a acceptance that policy needs to align. Second is infrastructure, and third is the demand aggregation. So RMI with Veto, we are doing this effort, which is divided into, right now it's in a phase 2 of it, and it's divided into 3 efforts and columns that we see. The first one is the pre-feasibility. So the pre-feasibility phase looks at the multidimensionality. So it's just not the economics everybody understand, but there is a technical feasibility, there is economic, there is regulatory, and we are trying to bring stakeholder readiness with it. So it's the multidimensionality that we are trying to figure out. The second one is the industry coalition building. Some of the players from India know, and some European players also, like when we are doing the VOC corridor. But in this also, we are in a process of building this industry coalition. We do it through an LOI, which we do, like letter of intent signing by all parties. It's primarily non-binding, non-legal, but it showcases an intent that everybody wants to come together and really make it happen, right? And the last one is unlocking the critical pathways. So the 3 levers that we talked about need more work. It needs work on aggregating demand and ensuring like what is that final delivered price. So everybody talks about the India price, but it's also important to understand that what is the willingness to pay at the heartland of Germany. What is the delivered price? And are we still competing? and what's the choice barrier which is making it or not making it happen, right? Alignment to RFNBO, I think it's only this much we can do as a group. There is a top down that has to come, but I think enough efforts are being made, right? And the lastly is the synchronizing the infrastructure, because whether it's Port of Antwerp, whether it's Gopalpur, Paradeep, all the ports have to actually synchronize. Supply and demand won't be able to do anything if actually the infrastructure is not ready, because you don't want it to lack, and it's a chicken and egg situation, right? Infrastructure companies won't start until they have a clarity of supply and demand, as you were mentioning, right? But it's very similar that supply and offtake is also in the same ambiguity, that infra will be ready or not. So we have to break that loop. So there is a need to align on that. So I think this is the effort that we are doing at RMI with Vito, and I'll pass it on to Joris to deep dive into the Vito study.
Big green button. Good morning, everybody. My name is Joris Vallée. I work for Vito. It's a research institute located in Belgium. About 1,300 colleagues I have, and we work in various fields in terms of energy, water, sustainable chemistry, materials, remote sensing, and also health, to name a few. And today, I would like to use one of the or two actually of the projects and models that we have been working on to show you a little bit what cost efficient modeling can tell us about molecules and hydrogen. Starting with one of our flagship models, so-called ETSAP implementation for Belgium. It's I would say the largest or the most complete energy system model that we have in the country. We built this together with various partners over the past 25 years, and quite recently also included a so-called coalition of various organizations across the energy field, going from producers, off-takers, utilities, and you name it. And we are actually very happy and proud about this model that we have built, because it is taking into account the entire energy system across all the sectors, industry, transport, domestic, and so on, and also across all the energy vectors, and even connects across the border for import of energy. And what we did, built 3 scenarios, because everything is uncertain. Models are interesting, but always wrong, and in a sense very useful. And that's what we don't want to do here is to predict the future, rather test what could happen, see which costs are driving or which parameters are driving costs, and also what is the impact of policy. The 3 scenarios are very briefly rotors with a stronger focus on wind availability, mainly far offshore in the North Sea, and also onshore. Reactors where we revive, on one hand, extending additional nuclear capacity in Belgium, but also allow for more nuclear to be built. And then imports, I think very relevant today. We look at the very low import costs, molecules, and how this could help, because there's one big elephant in the room in Belgium, and that is there's a scarcity of energy. It's a small country. It's a rather large industrial landscape and dense populated. Big energy demand, but little space and little resources to cover all the demands. Very quickly, don't press too quick. Zooming into the clean molecules, we're looking at what could be the role of that, but also looking at the policy context already mentioned by Gilles. Very important RED III regulation and how it could shape our future for the different sectors. And then, of course, as mentioned, energy scarcity, but also the uncertainty of the demand from the industry, which plays an important role. And there is not a one solution for all. Molecules are definitely needed, but for some sectors and some applications, we see definitely certain other technologies being more cost efficient, such as carbon capture or electrification. So let's have a look at the one zoom in of the clean molecules. And this one here is the role of molecules under the current framework. So with the ambition of applying RED III by 2050, one of the scenarios called reactors, and what we see is that there is a really strong import requirement for hydrogen and the derivatives, up to 90% imported. So that's almost everything. There's some own supply with mainly from SMRs, byproducts from refineries and chlorine, for example, but most of the molecules are imported. And the forms you can see on the blue bar, there's ammonia, mainly for ammonia as industrial feedstock, and some to the transport. Then e-methane is being a very interesting molecule for shipping. It's not that far off cost-wise from ammonia. However, there are some reasons why e-methane is chosen by the model, mainly because of readiness of the ships and the cost of retrofitting the engines. There's a bit of methanol and e-kerosene, mainly for the aviation. Again, this is not a prediction, this is not a business case tool, this is very brutal, sobering cost efficiency. What would happen then if the relaxation of RED III would kick in, or would for some reason be allowed or scaled back? That's something we can do with the model. Again, it's not a message to do it, but it shows that indeed own production of domestic production of hydrogen kicks in, and mainly through in the form of blue hydrogen, so carbon capture. Still a lot of imports for the huge molecule demands or fuel demands for shipping and also aviation. But it's a little bit less, up to 66%. So that was one. Now let's have a look at a little bit bigger scope, looking at our neighboring countries, more specifically the chemical sector, the cluster of Netherlands, Flanders, and let's say North Rhine-Westphalia, the province bordering Netherlands and Belgium. There's a huge chemical cluster there. About 40% of all the chemicals in Europe are being produced here. And they're all very much interconnected by rail, waterways, pipelines, as we saw from Air Liquide. There's a lot, we did an investigation on the trade flows, alternative feedstocks, and also an hydrogen and CO2 infrastructure model effort, and finally policy reviews. Let's have a look at this, I think very relevant for today. A modeling of the hydrogen, a potential hydrogen infrastructure. Again, cost-optimized modeling, looking at, on one hand, the location of off-takers today, mainly grouped in clusters, looking as well at RED III being applied, so the enforcing the use of green hydrogen in industry, and we see that across the different options to produce the hydrogen, and that would be centrally, meaning by offshore wind, or by import from the south of Europe by pipeline, but even ammonia cracked back to hydrogen. We see that decentralized produced hydrogen in 2050 receives, can be done at the lowest cost. And there is a hydrogen network. It's not the biggest one, but there is hydrogen flowing through the network. What happens if you would switch, if you would turn back RED III, then you won't see a hydrogen network. Not that the hydrogen demand has disappeared, no. The hydrogen can be produced at lower cost using natural gas with carbon capture, using the existing infrastructure, and using then a CO2 pipeline to store the captured CO2 in the North Sea. So these are two, we could say, rather extreme scenarios, but it shows that at least a level of uncertainty, that we heard a lot this word today already, can be derived from this, and has to be taken into account. And it explains maybe as well a bit some of the progress that is being done or that we see today on development of the hydrogen network. And finally, one of the last slides I have, this is also interesting. This is one step further down the value chain. So we looked at ammonia, next step, urea production, so a carbon-based fertilizer. What it would mean, this is a product that is traded globally. So we cannot only, let's say, look at the European competitiveness of this product, because then it will arrive in the port from another country at a lower cost. And you see today in Europe, this is the cost of producing urea, mainly fossil. You would add on top of it an ETS cost. And this is what happens if you would produce it completely green, quite expensive. For China, similarly, fertilizers are falling under CBAM. So you would apply, let's say, an ETS price out at the border when the fertilizer arrives. But you see that if China would greenify the product, they can do it already a lot cheaper. And the same for the US, a bit more expensive, but still at lower cost than the EU. And that was also one of the goals of this project, to look at the competitivity. RED III indeed can enforce the transition. However, in the case for urea at least, it would result in severe competitiveness handicap for the European producers. This is another aspect to this value chain. And finally, as a conclusion, and I think we can continue with that as well in the discussion, we see that on the current technology and cost assumptions and policy conditions, green ammonia can become cost competitive for fertilizers and potentially shipping fuel. But we also see that, for example, cracking of green ammonia as a hydrogen source will most likely not be competitive compared to blue hydrogen in case RED III is relaxed. And that's important because it's not the case today. That means that it can still be done, but it will be more expensive. And then the question is, who will want to pay for it? So having this said, I would like to thank you. There's no backup. And give the word or the mic back to the moderator. Question?
Short question. You said that if green hydrogen doesn't get developed, it could hamper the development of the hydrogen backbones in Europe, because then blue hydrogen would be a substitute and would be then produced locally.
Yes. That's what, I don't say that's what will happen, but this is what the model says, yes.
What about then the CO2 storage?
You
have the cavities in Europe.
There's the main projects ongoing now for CO2 storage are at the North Sea. So we did a calculation for the hydrogen network. Most of the lines can be repurposed of the gas network. If you won't do it, you can use the gas networks, and you will still have to build a new CO2 network to bring it to the port, and then later either by pipeline or by ship to the sea. So all of these costs have been taken into account, and that was the result of the model.
And that would still be less costly than implementing. That would still be. Thank you. That would still be less costly than implementing a hydrogen backbone.
Yes. The cost of the pipelines.
CO2 pipeline plus bringing CO2 offshore.
The cost of the pipeline hydrogen, it's a rather low element in the total hydrogen delivered. So it's mainly the cost of the hydrogen that is either imported or produced locally drives the whole, let's say, purpose or the whole cost of producing the product higher than if you would use natural gas. Of course, at given prices, I think we used 32 euro per megawatt hour natural gas. You would capture that carbon and you would store it under the ground. And at the ranges we have there, I think is between 100 and 150 euro per ton. So indeed, that is the conclusion, yeah.
Thank you, because it's always good to have the detail of the models coming from the conclusion to
Yeah.
know,
I have
know what
many
you have modeled.
Yeah, many more slides, and there's a full report that is published last
Thank you.
week. Yeah, so I'm happy to talk to you afterwards and yeah, look at the details. Any more questions?
Thank you, Joris. Yeah, I'm Jagabanta. I'm also from RMI. I lead the work on green hydrogen in India. We will transition, I think, with Isabel's permission, into a little bit of a moderated session with most of the speakers coming back. And we don't have chairs on stage, so yeah, we can just get a little bit of some chairs on stage, I think. Yeah. I'm going to request Prashant Chaubey to also be on stage. I'll just read out the expectations. Gilles, would be great if we could have you on stage. Joris as well. Marcellino and Robert, yeah.
And also some housekeeping rules. We just realized the session is also being recorded. It's not being streamed. Just to let you know, but we're not going to put this out, but if anybody has objections, please let us know, number one. Number two, the tea and coffee is just across near port 2, right? You don't have it right outside, it's just across. It's unlimited, it's available through the day, and there's some fruits as well. And finally, at 12:30, the networking lunch will happen right outside. But at 12:30, there's another session starting, so make sure once the clock hits 12:30, we step out. Jaga, back to you. Thank you.
Thank you, Nish. Great discussion so far. First thing in the morning, really appreciate everyone. We heard from everything to do with fairly analytical academic modeling to what real world considerations are when it comes to driving investments and and also a little bit of a snapshot on the India opportunity. So I do want to transition. We heard a lot on the Belgian side and the European side, but Mr. Chaubey is there. He is the president and head of hydrogen business with Avada. I want you to shed a little bit more light on the Indian opportunity for the Belgian audience here and what differentiates India's green ammonia opportunities compared to other potential sources of imports that Europe might be targeting. And you can reflect on the latest FIDs, the price discovery. Over to you, sir.
Thank you for the opportunity. I think one important aspect coming from India is that India offers those unique differentiating advantages which probably would be very, very difficult for some of those regions to replicate in India. If you look at the complete value chain, the single most important element is renewable energy itself. And that is where, because almost like 60–70% of the cost of this value chain comes from the renewable only. So that is a single biggest advantage to my mind. And because of very, very robust renewable ecosystem, which has been developed and implemented in India, along with probably one of the largest single grid in the world. And that's most important element to my mind. And apart from that, the cost of renewables. So India has given probably one of the lowest tariffs now, whether it's solar or even now, because there have been so much of a renewable into the grid. And to prevent that intermittency, now there is a major focus coming on storage solutions. So if you look at any of a renewable bid in India currently is known as FDRE, firm and dispatchable renewable energy, or round-the-clock solution with the storage. There have been a lot more focus on long-duration storage like pumped storage projects, etc. So the cost of renewable, which is very, very competitive, is a single most advantage coming from India as a region. Second is scale. So some of those developers who have really announced projects in India have been the one who have done probably one of the largest renewable energy projects in the world, and that gigawatt scale advantage, not only in terms of identifying and building a project, but actually implementing a project. So that's another advantage coming from my side. Third important is most of developers in India are not actually looking at hydrogen as a standalone solution. They are working across the value chain, and that value chain integration, so right from manufacturing to renewable to green hydrogen to fuels, methanol, ammonia, etc. That value chain advantage is single largest advantage that the India can offer, because the developers are not looking at a standalone project, but they're building the entire pipeline. And fourth is basically the policy momentum in India. So it's not only incentives or intent, but there's been a very, very clarity which is emerging now, which is into implementing mode. It's not only a green hydrogen mission per se, which announced in 2003, but the offshoots of mission and the sincerity with which the mission is getting implemented now. So for example, some of those tenders which has raised quite eyebrows across the world, being SECI green ammonia tender, which is given price. The reason of those prices are whatever in the assumption, I think renewable energy competitiveness, one, integrated value chain development. So for example, the right combination of nearby ports, availability of water, these are a significant advantage which has led to a very, very attractive prices for green ammonia. And now another tender has been offered, which is for a green methanol now. So this bidding momentum is also really fanning out that development. So I think these are some of those factors which are really important from my point of view. Thank you.
I'm transitioning to the next bunch of speakers, I think, requesting, of course, some reflection on what Mr. Chaubey laid out, the India opportunity. I'm going to direct this to Gilles as well as Gilles, right? If I'm pronouncing your name right. Marcelino as well. I mean, some of which was highlighted in your presentations and other presentations, the infrastructure chicken and egg, where you are kind of have to plan ahead based on mandates, which are shaky still, demand, which are shaky still, supplies that are originating, and you're also evaluating constantly, like, where is the opportunity, like, who is going to be the biggest supplier, and the tension between, of course, the domestic production as well as, supplies from abroad. Now, my question to both of you is, and this actually is a reflection for the Indian infrastructure needs that was for the ports. So Gilles, like, when you are thinking through the India opportunities and you are also evaluating other countries as a potential import source, how is it stacking up from your perspective? Second, I think relatedly is, how are you thinking through the possibility of, like, assets which you have planned for, which could be idle or which could be underutilized, and how you thinking through the economics and the financing of it? Because this is going to apply to the Indian ports and that ecosystem there from the exporters, and when they're starting to think about infrastructure planning. And partially, Marcelino, after requesting reflection on a similar question.
I'll start. So, first of all, I think reflecting back on what's being said from the Indian perspective, from our view as well, from Port of Antwerp Bruges, especially when we talk about green hydrogen, we clearly have an import strategy. I think, like Joris also mentioned, giving the high energy need, the high industrial energy need, the small country Belgium is, renewable electricity will be scarce today and in the future. If we need to have green hydrogen for certain applications, industrial, maritime, it's better to import them, and then again import them from regions where you have this low cost availability. India clearly is one of the front runners in that domain. We have an open view. I think there's an open market globally, but we see recent months, last year, and a bit longer, that India is going ahead just because of the reasons mentioned, the lowest cost, but also the strong industrial activity, large players that are there. So there's clear momentum, and I think that over the past few years, we've seen that this has been translated with us as well, but also with the other companies from the Belgian Hydrogen Council in a partnership, so that we can help develop that framework. Giving the import ambitions that we have, a few countries that are clearly front runners, it's key for us, for the port area, to develop hydrogen, ammonia, methanol. It's not an unknown. There is already some infrastructure. There are players there, and so that at least gives a bit of certainty or a framework in which to develop further. In the end, however, you remain with the chicken and egg. You take small steps, small progressive steps, so that by hopefully in the coming months, by the end of the year, when the demand is there, at least that base, you can continue with FIDs, with the first cases. But that doesn't stop us right now with the companies here present as well to test ammonia cracking, to build the first hydrogen pipelines, so that when that regulatory framework is there, you can take the FIDs to scale up, and then you have that larger scale infrastructure in place.
Yeah, well, I think there are two things. And the one side is how do we approach this chicken and egg problem, and in the other side is how do we approach the system in general. So first of all, how do we approach it in general is basically the target for us is to make sure that there is an infrastructure in Belgium that is allowing demand centers to absorb hydrogen, but also to be integrated within a European network, which is fully integrated. So the question here is to be able to connect global supply from India or from wherever it comes to demand centers, but also local production eventually. That does not need to be ruled out. Indeed, Belgium has a bit more scarce renewable possibilities, but there will be also some local production, and connect that to the demand centers, and of course to connections abroad. So we approach it in these three axes, three elements. So first of all, anchoring on the demand centers, early demand centers. So for us, is clearly Antwerp-Ghent area, where we see that there could be first movers, making sure that they are ready to be connected, focusing also on the connection to ports and to terminals. Even though Fluxys is indeed involved in the development of a terminal, we have a bit of a Chinese wall, and the pipelines are looking in a completely non-discriminatory way. So all terminals are being there are discussions with all terminals to make sure that timelines are aligned between when this product will arrive or will be able to arrive, and when is it going to be needed for the consumers. And the third point is maybe looking a little bit ahead, is make sure that there is an interconnection to the Netherlands and to Germany especially, because only in that way we will have a market liquidity of hydrogen. And there would be potentially additional hydrogen coming from the Netherlands, which has a bit more or better conditions for actual production. And of course, the big sink, which is Germany, they will be the big consumer, especially the Ruhr area and the Cologne area. We will see also that the most demand will come from. And on the chicken and egg, and how do we de-risk the whole thing? And I think that's important to remind the role that we already took. So basically, Fluxys already took the decision of a first investment in a pipeline. That was really in order to try to push the market forward. But now how we see things is we need to further the risk, and we need to make sure that there is commitments before we continue to develop and expand this network. So this has been done, as it was mentioned before, through a process of market open seasons in which demand players will book their capacities, and so we will try to de-risk it by phases, making sure that the demand is there and that the supply is there. And not only that, it's not only on the commercial, on the market development. The market development needs to push, of course, and they will be driven by regulatory framework, of course, but also we need to make sure that there is a ramp up of this infrastructure in a way that things are supported from a regulatory point of view, to make sure that the early movers are not penalized with higher tariffs. So there should be some type of adaptative of regulatory regulated tariff mechanism that allows for leveling up the tariffs, such that the upside of a scale up of the network will also be something where the early movers can also benefit from. And then lastly, of course, is the support in terms of subsidy So we have the European subsidy, we have CEF, the Connecting Europe facility, which is helping. But what we see now in other countries like the Netherlands and Germany, there is also further national support, which we see is also needed to make sure that this scale-up can happen.
Yeah, thank you, Marcelino. I'm going to turn to Robert. It's a bit of a spin-off from the similar question, but from a cracking facility perspective. We are at a state of scaling up a pilot. Joris's study kind of mentioned a scenario where cracking is uneconomical and should not be invested in, right? It's a possibility if the policy goes back and forth. It's an extreme scenario. I just want to play with it a little bit. But just building off from it, how are you weighing the kind of scale-up of cracking facility that Europe will require? And how are you managing the risk in terms of the build-out plan?
Thanks for the question, indeed. So I think looking ahead, it's clear that we have to scale up because at the moment, a lot of our energy is imported. So that will be also the case in the future. And looking at hydrogen carriers, it's also clear that we cannot produce all the hydrogen that we need locally. So there is a role for imports, and it depends on which study you read, whether hydrogen carriers will be imported, but 90% of it will be imported, or it will be some lower number indeed. So that's clear. I think the question more is at what pace will that happen? So if you look at 2050 numbers, it's clear because we need to be decarbonized. But what's really determining the pace is demand. That's really crucial, and that's been highlighted by various speakers today, of course, as well. And there and what some of the speakers have already mentioned is there's a distinction between mobility and industry. So there's mandates for mobility, and why does this work very well? Is because there you have a large pool of consumers that are that have to pay a little bit extra for products that are produced in a renewable way. And that's a kind of a way to increase the price of the end product with a small premium, and then that allows a green product or low carbon product to be produced. The difference with industry is, of course, that if you do the same thing for industry, then you get kind of an intermediate player that has to buy a more expensive product. And then the question is, how do you get the end consumer to pay? That at the moment is really very difficult. For example, the Netherlands is thinking about a mandate for industrial off-takers. It was also highlighted indeed. And that is maybe a good intermediate step, but in the end you really have to look at the final product, and there you need to require that the final product that the consumer final off-taker buys, such as green cars produced with green steel, these kinds of things are in the end the only solution to kind of ensure that there's demand. So turning to our cracking facility, of course, the only way we can build a large cracking facility is that if we have an off-taker that is willing to commit, or several off-takers that are willing to commit. So that's the only way we can manage this kind of risk. And for that we need to have government policies that ensure that there's a consistent demand over up to the next 15 years, so to say. So that's in the end the only way we can develop such a project.
Thank you. I have a slightly cheeky question for Joris, which builds off from the need for 10 years. I mean, modeling is, of course, driven a lot by inputs and assumptions, and it's only as good as the inputs, right? And that's why I was quite curious about the extreme scenarios. Now, this study is a little dated, considering what we are going through in terms of the West Asia war. I mean, on the positive side, the price discovery in India, where I feel probably those inputs were slightly dated. When you look at aggressive hydrogen prices that are being discovered in places like India, and on the contrary, the insecurities and the price, upward pressure coming out from West Asia crisis in terms of security of supply and cost of fuel, how will your scenario and your modeling, how will it change the output that your model is spitting out in terms of the 2050 demand? Like, what's your, if I'm putting you on a spot, like just trying to think through like how the model, logic will work. Yeah.
Yeah, it's a really good question. And first of all, as a researcher, I think we should invest in this cracking technology because it's It's an exciting technology. It's something you need to test on scale, and you're right. The input assumptions, especially for the ammonia to hydrogen, it's exogenous. So we haven't built a modeled cracker like we do for many other processes in the model, steel making through different steps and so on. So there's an ammonia price, and I'm also happy to hear that there's auctions at very low ammonia prices that we have to evaluate. And also for Air Liquide, yeah, we publish our assumptions, but I would really like to hang out more, so to speak, to learn about the results and also what we can take along in our models when it comes to these efficiencies. So that's one. And then also having to say, our model doesn't say you have to invest in it or not. I mean, this is academic, let's say, cost efficiency. But still, I think it shows certain directions. It poses questions like you were doing now, and that's what we need to have. This is the discussion. When it comes to energy scarcity, or maybe to, if I understood it right, the challenges that we have in terms of also geopolitics, typically we don't take this along in the model. We can do simple shock scenarios where we indeed lower a price or even make a commodity not available or make it available later in time. And the model will always find a solution. When I mentioned earlier, I think the gentleman is still here, about this cost, the trade-off of cost, blue hydrogen versus green in a world where policy can be chosen by the modeler. There's always a solution. It doesn't mean that it is cheaper than we produce it today. And I think that was also mentioned here. What we see, and definitely in the study we did with the trilateral chemical region, there is no scenario where you can produce at a lower cost than, let's say, before the energy crisis. These days are over. I think the way to overcome that, to hear about sticks mandates, and also about carrots, perhaps, where subsidies can help for capex, but also CFDs for bridging, let's say, the gap between fossil and green. These are the instruments that need to be developed. There are some of them there, they're not yet developed completely. And that's for the European market. When it comes to the international market, again, the conflicts that we see that drives our economy in a sense, and that makes everybody very nervous. There is CBAM, but it's also weak, so to speak, on some areas. It needs, there are cavities in it. For example, an Asian country could produce a green product and a gray product, sell the green product to Europe at a higher price and sell the gray product anywhere else in the world where CBAM does not apply. For the European producer, this is very tough to compete internationally. So there's that as well. And in the end, somebody needs to pay. Passing through these costs in the end to an end consumer, it seems to always happen in the economical model that we live in. So there needs to be made an awareness and call it the pre-me, call it the plus, whatever, so that the transition can also happen. And people know that, we do this because of, obviously, the threats that changing climate gives us. There's a payoff for that. Now, in the long run, and then I conclude, I believe that if we are the first movers and we take the pain and we find solutions and hopefully save as many or all of them, if possible, that you come out stronger from it. But it is not a given that it will just happen like that. There needs to be lots of work to be done still on the regulation.
Thank you, Joris. I think it's a good one to turn back to Mr. Chaubey. I mean, a lot of Indian developers are banking on European demands. We heard about degree of certainties and uncertainties around it, upsides as well, potentially in today's time. Specifically from your perspective as an Indian developer, what are the potential asks that you might have of European counterparties? And I'm using a general word, whether it's an infrastructure player, off-takers, or government. What will you require Europe to get their acts together for you to be better confident about putting your investments and taking FIDs in your project?
I think it's a great question. And long-term visibility or a bankable demand is something which every developer would be looking forward to. I think if we look at this is a very complex a system with very, very complex subsystem into it, right? So for example, ensuring your water runtime, ensuring your entire renewable energy integration, then the hydrogen block, then the ammonia process, then the ports, logistics. Developers are willing to take that risk. And in India, not only from the federal or a central government point of view, but a lot of state, I mean, state like Odisha, they're helping up in terms of setting up those fundamental anchors for CREATE. We are willing to take that risk. The only issue is that the willingness for a long-term offtake, one. Now, for a lot of offtakers, as we interact, I mean, there is either a caution because of they are not sure how the policy or the regulatory regimes will fan out in short to mid time. That's one. Second, probably also a hesitation, wherein from a developer point of view, we have got the timelines. Entire renewable energy, a lot of other things have timelines which have a regulatory approvals in place, and you need to deliver those projects in terms of timeline. And that gap between hesitation or timelines that need to be bridged. So I think willingness to go for a long-term contract, and you have there are a lot of flexibility. So we can discuss on the pricing frameworks, which really help to conclude the process. But I think long-term offtake willingness plus very, very stable and good pricing framework. So I think that is something which should be the first anchor point as an Indian developer look at Europe. Second important aspect is again policies and harmonization of those regulation and standards, which are very, very important. We believe and we understand, so every region has a right in terms of looking at its own ecosystem and frame those regulations which are important to protect that ecosystem. So we are fully aligned with that. Sustainability, traceability, everything is very, very important. But I think today we also need to look at a very, very pragmatic and practical pathways, right? So that the process itself does not become so complex that it's really become very, very difficult to implement the project at the end of a day. So we should not be mastering the process of perfecting the regulations to an extent that it really becomes very difficult for a harmonization of those regulations. Because from a developer side, a country like India, there are certain advantages. There are certain ways in which the harmonization is required. Let's say, look at just one point, for example, let's say RFNBO. There have been a lot of issues to and fro, which we are trying to discuss in terms of, let's say, one single point of a single bidding zone, for example, right? Now in India, if you look at India, the power market in India is a long-term PPA-based market. 90% of the power, 95% of the power in India is transacted through a long-term PPA regimes. Unlike Europe, where a market or a short-term and mid-term markets are very, very prevalent, right? In India, it's just a 5% of electricity which is through a short-term market. India is anyway a single bidding zone. There is already a single grid available. Now the question of interpretation, whether it could be treated as a single bidding zone itself becomes an issue. From European perspective, 500 kilometer is a good boundary line in terms of having your electrolyzer and your consumption point. But look at in India, in one state only, it's almost like 1,500 kilometers, right? So these are certain things. It's a pragmatic resolution would really help because we are having those costs. So I think that harmonization is a second important point in terms of policy clarity, which we'll like to look at. And then the current crisis which have come up is also a great time for EU as a bloc and India to have this really green energy partnership. And if we are not able to do it in that time, I don't know what would be the right time to do, because nothing best could be at this point of a time where there is so much of a complementarity, but I think we are not ready to look at that complementary solution to help each other, and that's fair, because there have been a lot more focus on the climate imperatives, so because of lot more geopolitics, geoenergy, and lot more things, so the climate imperative seems to have gone to the backdrop for a while, and the pressing problems can come up. But if you simply close your eyes, it doesn't mean the problem has disappeared, right? So it is gonna come back and haunt, and it's a question for because climate doesn't know the boundary. It doesn't follow the national boundaries per se. It's a larger thing for the humanity. So I think that complementarity needs to be harmonized and looked into. And third is preparedness from infrastructure point of view. So we're seeing a lot more development happening. I think last month, same time, I was in Belgium. I especially visited the cracking facility where we have interest in terms of discussing it and taking it forward. So I think all those things in terms of your import terminals, your bunkering facility, cracking facility, these are again becomes a very important point as a developer looks into. So I think these 3-4 are very important thing as I look at from a developer perspective.
Thank you, Chobaji. I'm going to ask the Europeans to react a little bit towards it in terms of elements to do with maybe Marcel, to do with the RFNBO and the regulatory heaviness around which this sector operates. They're good and bad thing. I think market is being built largely by regulation to a degree, but it's also like there are challenges around overcomplication on standards that Mr. Chobe is highlighting, which is, at least from the exporter point of view, it's always a point that we like to raise from exporting country. Like, what kind of regulatory direction can probably accelerate this in all the lights of the disruption that we're going through? And of course, we can't forget the shadow of climate as well. But any large reflection on this? I know I'm probably taking you a little bit away from the infrastructure core questions here.
Well, I think the first thing regulatory-wise is not a new direction, but it's basically a direction. It's just to have some stability, to know exactly how things are going to look like, and not having the change of direction that we are seeing quite often. So I give, just as an example, what happened with, maybe wait.
The open for the opening ceremony at 1700 hours.
Sorry, I'll try to recatch. Yeah, so it's about the stability. And I just give an example of things that do not help. It's what happened with CBAM earlier this year, and all the, of course, we are in a very complex political situation, geopolitical situation. There were some movements in Europe which do not affect the hydrogen or the energy sector. There were basically farmers that made that there were some announcements and some proposals being made that affect the hydrogen and the CBAM in this case, with the potential threat of having ammonia taken out of CBAM. Well, these things do not help, because at the end of the day, they create a lot of uncertainty, not only at the European side, but also eventually the Indian side. I think CBAM in this case maybe affects more like the blue hydrogen projects. But anyway, I mean, it's just an example. And the other thing is basically something that was shown before in the presentation of there is still a market fragmentation in Europe that also does not make it easy. So when RED III is not the same everywhere, that creates it creates a problem because it's difficult to understand, and it creates a problem because also there will be different speeds in the different countries. And just the example of the difference between Belgium and the Netherlands. I mean, we are so close, and at the end, the objectives are going to be different in terms of RFNBO targets. Yeah, so I think there are two things: a bit more stability and less fragmentation.
I think you have a point, yeah.
Yeah, thanks. I wanted to make similar points regarding the rules for producing RFNBO, so renewable fuels of non-biological origin. So in Europe, we spoke more than 2 years about what exactly should be the rules for RFNBO. And actually now the European Commission announced that in June they will come up with a proposal to kind of simplify these rules a little bit. And from our perspective, indeed, it's important that this does not create a lot of uncertainty again, so that any adjustment made to these rules is now done quickly, quick and dirty, so to say. So without opening Pandora's box, because everyone needs certainty what the rules of the game are. in order to be able to develop the projects. And looking at it from an Indian perspective, I think it should be pragmatic indeed, without disregarding kind of a level playing field. I think the balance should be found that there's a level playing field between domestic production and imported production. As long as that's the case, I think it should be as simple as possible. So that's one thing, and indeed, also highlighted by a previous speaker, the fact that everything within the Renewable Energy Directive in Europe is done in a different way in each member state. It's also not so really makes it complicated also for developers outside of Europe, but even inside of Europe, it really complicates things. So it would be really helpful to have kind of a common framework across Europe.
Yeah, thank you. All good points. I want to turn to you, Gilles. Quick reflection as a port, and this ties it a little bit with my earlier question. Like Indian ports, and we work with majority of at least two of the ports, and we understand the challenge they have in terms of infrastructure planning. I mean, you guys are way ahead. We interact with your colleagues in India quite frequently. What, from your perspective, like how should Indian ports think about infrastructure planning from the kind of setup they need to think through, financing, ownership models, etc., that can actually accelerate the planning, considering all the uncertainties of supply and demand that we have been grappling with throughout? Like, how should they think about it? Should they start putting in assets in the promise of a demand that might materialize, like Europe went ahead? Or should they be thinking through working with, let's say, a degree of offtake certainty, which is a topic we have been circling back towards, before committing to infrastructure planning? Like, how should that be approached from your perspective? And what can Port of Antwerp do? I know because you have an international arm, right?
Yeah, well, tricky question. I don't want to create the impression that I have the answers to all these type of questions. What I do know, or indeed, we focus on the infrastructure developments in Antwerp and in Zeebrugge. We're a strong chemical industrial cluster, which allowed or made certain no regret options feasible, and so to build this scale. And like you said, we try to put that expertise also out there internationally. We have an international daughter company that focuses on port development globally. Historically, this was the case to enable or to strengthen trade routes for certain types of products with Latin America, with Africa. But more in the recent years, we have also seen that in the energy domain, this can bring advantages. We're, for example, present in Oman, in Duqm, in the port area there, because we see that indeed in this energy domain, in making or developing the framework from renewable electricity to a hydrogen carrier, to storage, to export, you need some infrastructure, you need some common grounds. And we have that expertise from Antwerp and Zeebrugge, and we try to bring it in as well into those international developments. But I cannot say that there's like a general solution on how to do this. There's no regret aspect to do, but it is communicating a lot, facilitating contacts between producers, between off-takers, following up on the regulatory framework. And that's something that we as well have learned in a complex environment, which is Europe, which of course also through this international daughter we can bring on the table. So happy to discuss further, happy to work on the Indian-Europe value chain and see both from an Antwerp, Bruges perspective as well from an Indian port perspective how that infrastructure can be built out.
Yeah, thanks, Gilles. Joris, last thoughts, comments before I wrap it up. I've been asked by the organizer to wrap it up, but anything you're reflecting on both the offtake uncertainty issues, the regulatory issues? I think a specific question could be like, what could research organizations like yourself, who are seen as objective and neutral and techno-economic or quantitative in nature, do to provide the certainty that to the market and to regulation that we could require right now?
Yeah, we don't provide that much certainty in the sense that, oh, we do. You could argue there. There's always something to say about cost efficiency, because in the end, a lot of these projects or a lot of the infrastructure for the early movers, there's a risk, and often the state intervenes, meaning taxpayers' money, and every politician wants to be able to face their voters and say, look, we have done our due diligence, we looked at everything. But it can only take you that far, because specific business cases, specific risks still need to be taken, I think, to move forward. About the no regret comment that you made, Gilles, in the early days, years ago, I said, yeah, of course there's no regrets, but the more you look at it, and the more you look at the specific cases, there's always some kind of risk that you need to be able to manage. And when, I don't know if you remember the first picture that was ever shown of the hydrogen backbone of Europe, I think by Guidehouse. It was just like, wow, Europe, pipelines everywhere, all the clusters connected. It looked like a visionary paper, and it made sense in a way. Now we see that where it does happen, the action is in the industrial clusters, often close to ports. You can really, let's say, make the risk smaller, get the contracts in place, make it move first, and then build the corridor from there. And along the way, hopefully, because there's RFIs also that Fluxys has done, from the moment they really need to put sign with blood, so to speak, the ink, and say, yeah, we are committing, then you know it's going to happen. But 2 steps back, I would say, start small and expand from there. And what we can do to help with that, you can always, of course, ask us to bring your case to a system level, what typically that we do, and then you can also see, yeah, it might make a lot of sense on paper for this business case, but if in the end you need to knock on the door for support, for a subsidy, it's often that these kind of stakeholders, they look at cost efficiency. So if you take that pot hand in hand, at least the surprises will be upfront.
Thank you, Joris. Quickly summarizing, excellent discussion. I think a very complete discussion, in my opinion. Eventually, we all circle back to the offtake guarantee and trying to aggregate this demand and keep it less fragmented. Regulations were highlighted, infrastructure sequencing was highlighted largely, but I really appreciate the panel today and really appreciate the Belgian Hydrogen Council for the opportunity to help you out as a knowledge partner. But yeah, I want to pass it to Nish. Thank you so much, guys. Yeah.
Thanks. Can we just stay back for a photo? Yeah. Well, we have another session taking place as well, again organized by another Indian organization. So if you'd like to stay back, you're welcome to. If anyone's on the Power2X Honeywell visit, you'll have to head out for your bus right now. So just a word of caution for anybody in the room. I think Dr. Anand is on that trip, so Sayak can guide you, and also anyone else. Sayak. So thank you once again, and Isabel, thank you very much for putting this together, and Robert, Giles, all of y'all, you know, it's been wonderful hearing y'all. We'll make sure we'll send these presentations around. Thank you.
Now we invite you to the lunch. It's offered by the Port of Antwerp Bruges. Not to forget, and we can continue talking about all the opportunities and roadblocks and ambitions.
Thank you. So lunch is served just across the room. If you're looking for it, thank you.
Hello. Hello. Please be seated, please. Now we're going to start the next session. Is green hydrogen is shaping the world order, securing supplies, scaling capacity. I'm calling Mr. Rahul Munjal, sir. He's the MD, co-chair of CNSA Committee on Renewable Energy and founder and chairman of Hero Future, to lead the session.